Thank you. Thank you, everyone, for coming. So I'm going to be talking about learning to rank data sets for search. As mentioned, I'm a data scientist at Xoom, which is a PayPal service. I'm interested in, well, my interest started with data management. Then I started getting interested in dataset search, and more recently, I started reading and getting involved in learning to rank. Previously, or at previous Spark Summits, I've given talks about that have sort of built upon each other. So first I started with a talk on running Elasticsearch inside a Spark cluster, specifically inside the driver node of a Spark cluster. That was in Spark Summit Europe in 2016. The next year, in 2017, I talked about, well, we have a Spark cluster which has Elasticsearch Inside. We can index data sets. And so in that talk, I showed how our data sets, which is a publicly available collection of data sets, could be indexed and searched for. But what that was lacking is that, well, search queries one would have to be very precise into what one wanted to search for. And so when I started trying to implement this at Xoom, well, I started thinking about the users coming from different teams inside the organization. And so it would have been really difficult for them to find the data sets they were looking for. And that's where I started getting into reading about learning to rank. So the whole idea here is to learning to rank data sets for search, where we have a population of users who are very diverse, come from different teams, and therefore their search criteria are going to be very different, right? So that's sort of the broad idea of what we're going to be discussing today. For the agenda, I'll introduce the problem statement and motivation, so expand a little bit on the previous talks, give it a little bit more detail. I'll talk about Elasticsearch Learning to Rank plugin, which is what I used to develop this. I'll discuss a little bit of the data pipeline that I've been testing this on, and that refers specifically to extracting metadata from the data sets that we're indexing, and as well as extracting a judgment list that can be used as an initial step towards learning to rank. I'll show a demo, which is very simple at this point. It's really the beginnings of a dataset search engine with machine learned relevance ranking. And if time permits, I'll open up for Q&A. So the problem that I've encountered, and this is not only at Xoom, I've heard it from colleagues at other companies. I've read about it. I'm sure you have as well. And the problem is that datasets are nowadays key corporate assets. But despite that, they are generally not given the importance they deserve. And as a result, they're hard to find. I've had colleagues come to me, not only at Xoom, at different companies as well, asking for specific data sets. And there's really no interface in which they can easily search for them and maybe start to develop their own processing pipelines for data. More specifically, nowadays, it's teams within these organizations that are having a hard time finding and therefore starting to use the data sets they're interested to learn about or process. And so, well, as I mentioned, the idea came about to start indexing data sets. And that's what I talked about at Spark Summit East. If you want to check the talk out, basically what I'm doing there is I'm extracting metadata from the different data sets and using that to index. Now, ranking is what is of interest now so that we can make search results relevant to users. And so that's going to be today's topic. So first, a couple of questions. How are data sets usually ranked, or how are data sets really ranked? And more specifically, can judgment lists, which are useful for ranking, be generated at dataset production time? So this idea of extracting something at the time at which the dataset is produced is key both in the previous talk, which was focused on indexing, as well as on this talk, which is focused on ranking. The idea is, we're processing and generating data sets on a Spark cluster. Can we extract metadata, or can we take some useful relevant judgments that can help us bootstrap some sort of ranking for the data sets that we're indexing, and ranking, obviously. So that's sort of the general idea. But let's take a look at sort of a pictorial overview, or sort of architecture. So this is what was happening in the previous talk I gave. I was indexing our data sets onto the driver node of a Spark cluster, where, so there's 3 screens here, I'm going to point to one at least, where we're running Elasticsearch inside the driver node of the Spark cluster. The idea being that we can generate an index, take a snapshot, and then restore that snapshot onto some sort of production Elasticsearch service or server. More specifically, the indexing consisted of, well, extracting different metadata, like the file name, the format, field descriptions, type information as well. In this case, it was all CSV files that together represent the R datasets collection. And so basically the idea was to go over each and every dataset out there in the R datasets and extract all this data, all this metadata. And so that can be sort of extended to any data set that you have on your data lake, or that's available as a result of running a specific data pipeline that produces a lot of data, for example. And I sort of like to draw a parallel between, like data lake is like a train station, and the trains are like the data pipelines, and perhaps the passengers together are like the data sets that are produced. Some pipelines have more frequent trains going back and forth. More data sets are produced. And so generally with this idea, I started thinking about things, and I thought, first of all, we want to organize what we're going to be indexing and ranking, and namely that is data sets. As I mentioned, data sets that are either produced by a data pipeline that frequently generates data sets, or data sets that are already available on a data lake. And specifically on today's talk, the focus is on having this ranking function that can help us rank data sets differently for different sets of users, and do that as part of a running data pipeline. So same idea as extracting metadata from the data sets. Well, might be interesting to also extract a relevance judgment. And the idea of extracting a relevance judgment is to sort of bootstrap a dataset rank model. So already from generation time of the datasets, we can know, for instance, this particular dataset is of interest to the marketing team. This other dataset is of interest to the sales team. And a third dataset might be of interest to the data science team. And if we can, after that relevance judgment, after extracting those relevant judgments, if we can incorporate some sort of feedback loop, which might be something we could think of adding in terms of when users click on datasets that they find as search results, that's sort of an indicator that the dataset is of interest to that particular user. And so if a user clicks on a dataset, we might be able to figure out which team they come from, and therefore start drawing some conclusions that serve as feedback to those initial relevance judgments that we extracted, sort of to validate them or to make them more concrete, so to say. And so all of this, I have a picture in my mind which looks something like this. it's a little bit involved, so let's go ahead and build it up. So first we have, might be Excel files, might be CSV files. Those are all the input data that, that we have a data pipeline for processing. And we use Spark for that. We might want to generate reports in something like Tableau, for example. So that's the starting point. As I mentioned in the previous talk, I focused on indexing all these data sets that are produced by extracting metadata from them as they're being processed. So that enabled search in an Elasticsearch cluster, and there's the population of users started issuing search queries. But those search queries were, you had to be very precise about things. So today's talk focuses on these relevance judgments, which can also be extracted, and the feedback logging that can be incorporated afterwards. So those both are the sort of new ideas that I'm talking about today in this pipeline. After that, data sets that are generated, indexed, and of which we can extract relevance judgments might also have some sort of data set profile page that describes the data set, which team generated it, what it describes, what it's used for, sort of data that's useful for anyone that's consulting and searching for the data set to get more information on. And since we're already creating data set profile pages, we can even build like team dashboards, sort of collections of data sets that are organized in one central place. And this could be specific to my use case, but I thought it was useful to include it anyway. And the idea is to enable users to issue a sort of a command so that a data set is fetched from a data lake and it activates a data pipeline that goes through the entire process again. So this could be a user wanting to re-index and re-evaluate a data set for relevance, possibly because they reached the data set and it's not relevant for them, but it showed up as one of the first search results. So the user could activate the entire process from the dataset profile page. And overall, the idea is to generate an index that can be exported out of the Elasticsearch cluster, because that's not really our production system for search. So once we have indexed, ranked, and produced all this useful information for searching, we can sort of pull it out from the driver node of the Spark cluster and use it somewhere else where it's more sort of production ready. So specifically, how do we rank data sets? And here we're focusing on ranking starting off ranking with relevance judgments that can be extracted from the data sets. And particular to this talk is this focus on immediately after the data set is generated, we attempt to extract this relevance information from possibly available from the data that's part of the data set or some other metadata that we're able to extract or pick up from another source. And this is all used for producing a ranking function that can be leveraged for training and used to bootstrap a dataset rank model. And I'm sort of comparing two ways of accomplishing this, sort of my team's way, which we call posteriori. And we read some research papers, and for example, Halevi and team, they prefer to do things after the fact, so post-hoc, not as part of a data pipeline, but once the data sets are available elsewhere, they have already been produced, there's a sort of a mechanism to extract metadata from data sets that are already out there. Our focus is indexing, ranking, for stuff that as stuff is being processed or analyzed in a Spark cluster. So once we've extracted these relevance judgments, to be more specific, in the feedback loop I was referring to, we can use click-through data that would provide us with implicit feedback that is useful to adjust those initial relevance judgments. So maybe we picked up on the wrong signal and the user clarifies that for us, either like the example we were discussing, by reissuing the whole process, or simply by saying this is not relevant for me. So we could incorporate sort of a star relevance judgment, like 1 star, 5 stars, is it relevant for me or not, inside the dataset profile page. And so you might recall this part of the overall picture. We have dataset profile pages, and we can incorporate this mechanism of giving feedback for users. So about those two sort of approaches to this problem, Halevi, they advocate finding data in a post-hoc manner, and we propose another approach, which is we focused on indexing immediately after the fact, whereas Halevi and team focus on indexing after the fact. So even outside the Spark cluster or whatever is being used to index and process data sets. So let's discuss a little bit about the pros and cons of our approach. So we think that extracting relevant judgments can be useful because we can sort of leverage them to bootstrap an initial ranked index from data that's already being processed. And if we can incorporate a feedback loop, then we can validate these sort of beliefs that we extracted initially. Another advantage is that more granular metrics are available to evaluate the regeneration of metadata. We can also expand upon it. So if we find additional metadata, we can reissue the whole process again, reindex, re-rank. So this is all sort of inside the same ecosystem of tools. We don't need to wait for things to happen again because we can actually activate their happening again. Now some of the cons. One disadvantage is that model development outside the Spark cluster is going to be disconnected. And even though it can be validated through some sort of feedback mechanism, that's still disconnected. It's not something that we've attempted to continuously run this or provide users with the ability to reissue the process. But even then, it's still a disconnect. It's two disconnected systems. The search system is not the data processing system. Another sort of con that we realize is that we're looking at the trees instead of the forest. So instead of having a broad vision of all the data sets that are out there, as in this post-hoc or after the fact method of ranking or in indexing, we're focusing on individual data pipelines. And that sort of gives us a narrow vision on only being able to extract metadata that's coming in that pipeline, for example. And another sort of con, although it could also be considered like an advantage, is that the need to replay the indexing pipeline when things change. The reason I think it's an advantage is because users can actually be involved in that process. And that can help to give us feedback whether something's relevant or not. So with that, I have a very simple demo that I want to build up to. So there's a few slides about that. So we have, I tried to search for an example that would be sort of illustrative. And what I found is, well, I started thinking of movies as datasets. And so there's this very useful TMDB movie database. And so I started thinking of movie pages that are available in TMDB, such as this one, which give details about different movies. I started thinking of that as the dataset profile pages. So those profile pages that users would get as search results that enable them to explore datasets in more detail. And so the particular example that I thought of is, well, if I think of the marketing team as a team that's interested in war movies, where movies are datasets, we could call that the war team. So let's sort of explore movies from the perspective of the marketing team or the war team. So if we look at, there's 3 movies that I looked at for this demo. First, there's the original Rambo movie, which has this sort of unique identifier in TMDB. It is not a war movie, so in terms of its genre. However, inside the keywords, it does mention the term war. Second movie is Rambo 3. It does have a genre of it being a war movie, but it doesn't have the keyword war. And third movie is Rambo First Blood Part 2, as well a war movie in terms of its genre, but again, not mentioned as a keyword, right? So what would the judgment file look like? Well, we have the war team, which is here QID 6. Here's the 3 movies that we discussed. And we're basically saying there's a relevance grade that we're issuing to each movie. And this is what could come out automatically from the data pipeline as we're processing the data set. We could already say whether something's relevant or not. In this case, we're saying, well, these 2 movies, Rambo 3 and Rambo First Blood Part 2, these are highly relevant, whereas the movie Rambo itself is not relevant at all. So what happens if we search for Rambo? That's the first question that could come to mind. So let's give that a try. Well, Rambo comes up as the first search result, and that's something that needs to be tweaked. Oh, sorry. Thank you. Here we go. So I searched for Rambo, and it showed up as the first search result. What needs to be tweaked here is there's a much higher weight on the query we're issuing based on the title of the movie. But that's something we could change. But interesting, however, is the fact that we see Rambo 3 and Rambo 2 in there. So what would happen if we search for something like War Rambo? Well, the results here are interesting. What used to be the first search result is now sort of the 5th or the 6th. And Rambo 3 and Rambo 2 are the first 2 search results. So here the team name, remember this was the marketing team, is having an influence on the search results. Same happens if we issue a query for something like Rambo War. We actually, I think we get the same ordering. So I think, at dataset processing time, we could already start extracting these relevance judgments and using them to bootstrap, influence the ordering or the ranking of datasets as they're being processed. So what have we seen? How to rank datasets on Elasticsearch using learning to rank. For that, I used a plugin that's available. It's open source. We extracted relevance judgments immediately after datasets are generated in Spark, and we showed a very simple demo that basically underscores that idea. Some next steps that we have discussed in the team for sort of things we could start doing after this. Well, since Google recently came out with their dataset search, we started reading about that. And so we thought it'd be interesting to describe datasets in a structured or schema.org way, seeing as that is now becoming the standard. Since we're focusing on teams and individuals inside a company or organization, it might be useful to build a knowledge graph. And so one of the guys said, well, if we're building a knowledge graph, we could start using GraphX and maybe play with that. And something else that was discussed is using topic models. And so something like the Glint parameter server, to build topic models based on structured data sets and have them, have them be more generally available in memory in a cluster, so that we could stop looking at the trees and start looking at the forest if we manage to have sort of many data sets at the same time that we could compare, rank differently, evaluate, because everything's on the parameter server. So at this point, these are just ideas, but they could be useful someday. And these are some of the references from papers and stuff we read. And with that, if you have any questions, I'd be glad to take a stab.
Hi, thanks. So if you're aware of, let's say, Cloudera Navigator or other indexing engines, would you be able to compare the running Elasticsearch inside the driver with them?
So I'm not aware of these, but in terms of comparing how relevant something is for a user?
No, like what extra benefit gives you having Elasticsearch as a separate pipeline, ELK stack bringing into the Spark driver instead of having Cloudera Navigator, which could do the same thing you out of the box if you have a Cloudera cluster, for example.
I see. I'm not sure, though, if the Cloudera version that you mentioned runs inside the driver node of a Spark cluster. I guess that would be one difference. In terms of comparing performance, I can think of the fact that it runs on the driver node as being something that wouldn't be so beneficial. But I do consider it being useful, as for us, it has simplified not having to index or do stuff on an Elasticsearch server that's running somewhere else. Or in other words, we can directly interact through the same code that we issue Spark with the Elasticsearch server. So I can think of those as being differences.
Thanks for the talk. It was very interesting. So I just sort of want to get this straight. When you have the data set prepared, and when you're indexing it, or is it immediately after, before you index it, you extract the relevance judgment?
It can either be before or after. Right. The point being, if it's part of the same processing pipeline,
right?
Either if you do it before or after, you're still doing it.
Right.
You don't have to wait for the data set to be out there and go out and pick it up, so to say.
Okay. And so at that point, you use the extracted relevance judgments to train a learning to rank model. Is that correct?
That's correct. For example, we could know from the start that a specific data set we're working on, that pipeline in particular, produces a data set that's highly relevant to the marketing team. So we could use that knowledge to incorporate it into a relevance judgment.
Right.
And that's only one example. Anything you can think of, you can incorporate as relevance judgments.
Right. And then you also mentioned the use of click-through data. So do you use that? You use that click-through data to modify the original relevance judgments that you extracted?
Exactly.
Okay.
So it's sort of, the way we envision it is sort of validating what we initially issued relevance judgments for.
Mm-hmm. Okay, and just one last question is, since you are extracting the relevance judgment right after the fact, does that mean that the LTR algorithms that you use are all point-wise approaches? So you don't have like list-wise sets of like a rank. I guess the relevance judgment is not in a ranking of the data sets. It's rather just like number of stars or something like that.
So what comes to mind is this difference between seeing the trees and the forest. And one limitation is that
Right.
at processing time, we only see what we can see.
Okay.
And that's the reason we're searching for a way to have everything at the same time.
Okay, great. Thank you.
All right, thank you, Oscar.
Thank you.